In this video, we'll discuss CRA models for fraction subtraction with unlike or different denominators. So the example we'll look at is 3/4 minus 3/8. So again, we'll start with our 3/4. All right, so this is 3 of the 4 equal parts that would be needed to make this whole. And we want to take away 3/8. Okay, so if we're looking at this, right, we want to subtract, so we want to take away eighths, and we want to take away 3 of them. If we're looking at this starting amount here, the only pieces we have are fourths, right? So we don't have anything shown in the model here that are eighths. So our first step here is that we need to represent this fraction, this quantity, or this area of the whole in terms of eighths so that we actually can subtract those 3/8. Okay. So since we have fourths, right, what we can do is we can double the number of equal parts that it makes to take up the whole, and double the number of parts that we have, or another way is to think of cutting each of these in half. Right, so instead of that one part, we have these two. Right, another 2. And another 2. Okay. So now instead of having 3/4, what we have shown here is 6/8, and we're able to do that because they're equivalent fractions, right? They take up the exact same area. Okay, I'm actually going to remove these fourths from the bottom here. So just to show our trade was equal, an equivalent fraction. Okay, so now I have 6/8. I want to subtract 3/8, so I have eighths now, so I actually can take away those 3/8. I'll take 1, 2, 3, and then what am I left with? I'm left with 3 pieces, and the name of those pieces are eighths. So my difference, my answer here will be 3/8. Okay, so that is our concrete area model, and we'll look at concrete length model with the fraction strip. So again, starting with a length of 3/4 of that whole. So we need to take away 3/8 of this length. We don't have lengths eighths represented. So again, we need to find an equivalent fraction. Okay. So we found that 6/8 is equivalent, right? We're just splitting each of those fourths in half. We can see they're equivalent because they're the same length. So now from this length that I have, this 6/8, I need to take away 3/8. And we can take away that length of 3/8, and the length that leaves, the difference that leaves, is 3/8 again. Okay. All right, so those are the concrete models. For representational models, again, kind of this same type of idea, but how we're showing this equivalent fraction here. Again, in the area model, we have those 3/4, but we need to take away eighths. So you can break this whole model up into eighths. Okay, so I can take away this one, and this one, and this one. So here's an example of where we might want to just draw x's in here rather than erasing, because as the quantity would increase, maybe we might lose track and we're not sure how many we erase. So we can verify that we've crossed out or subtracted 3 of the eighths. And that leaves me with these 3 pieces, and those are all eighths. So my difference, or my answer, is 3/8 there. Okay. In this number line, all right, so we're at 3/4, so we're going to subtract 3/8. We're going to move 3/8 in the left direction. So this is a case where we don't have those tick marks, so we can't just make those hops. All right, so we have to, again, this is kind of drawing in these additional tick marks for eighths, is this idea of kind of finding those equivalent fractions here, right? So I'm going to draw these down below. 1/8, and then again, we're kind of thinking of this in terms of eighths now. So 2/8, 3/8, 4/8, and then 5/8. Okay, so then we just need to subtract 3, or in this case, in the number line, move 3 tick marks to the left. So 1, 2, 3, and that leaves me at 3/8 there. All right, and then for the abstract model, all right, we'll kind of do the more drawn out version of this, since this is our actual standard algorithm for fraction subtraction. So again, the first thing that we did was, right, for each of these, let me put the length model back up here. And for each of these fourths, right, we traded each fourth with 2/8. So instead of having this one piece, we have 2. And then instead of needing 4 pieces to make up the whole, we would need 8 pieces to make up the whole. Okay, so this action here, going from the fourth to this 1/8, and then same for the others, that's this idea of, right, we're multiplying our numerator by 2, right, from 1 part to 2 parts, and then multiplying the denominator by 2, since we now need 8 total parts to make up the whole as opposed to just 4. Okay. So that's our standard algorithm, right, is if our denominators don't match, the first thing we need to do is find a common denominator. So in this case, we can find that the 1/8 is the common denominator. Okay, so this 3 times 2 over 4 times 2, right, got us to 6/8, and that aligned with everything that we showed in those concrete models, because we eventually had only those blue pieces, only those 1/8 shown, and we wanted to subtract the 3/8. After we did that subtraction, what that left us with is 3/8. Okay. So similar for the concrete and representational models, and then again, this is using that equivalent fractions algorithm as part of our standard algorithm for fraction subtraction in the abstract model there.